To begin with, we had a catastrophic failure. It was a perfect storm that led to the clear well going dry, which is what supplies water to the town. If there would have been a fire, the firemen would not have had any water coming from the hydrant. So it categorizes as a catastrophic failure. That's not a common thing, but it certainly triggered this as a need to stay more on top of our infrastructure. And so that and the aging technology drove this. That knowledge loss that comes from retired resources had a whole lot to do with that as well. And then there are further operational risks or costs, I should say, that aren't as high as a clear well going dry, but they still matter. One such case is wastewater has blowers, and they'll work more often as you have more influent coming in, and less often as you have less. Where the sensor is located to sense it can be fooled, and so they're struggling with the physical location, whether they can change it. But in a downpour, you're running constant because it thinks it has to, and that can wear out a $30,000 to $40,000 blower. After the catastrophic failure, we took a cloud-native platform approach. Not to go into too many details, but that was a struggle. There was a need to pivot, and fortunately, I was introduced at a time prior to when I had to pull the plug to EdgeLake, and okay, this is the path. The local processing is one of the reasons it's the path, and so we changed directions using the EdgeLake for this solution. AnyLog is lightweight; it could sit on a very small computing device. So in that setup, by comparison to the struggles we had before, when it was time to set up and configure the system, this is an hours to do thing in many cases. It could be days depending on what your architecture is. That's a duration as compared to your more traditional project. When it's time to ingest the data into the data lake, it's also an hours to days effort, and AnyLog will build your schema for you. You're not having to have SQL skills. That's a kind of a low code, no code advantage. Then building the queries to pull the data out so that you can visualize it, integrate with it. That was quicker in our case. That was hours. And then we used Grafana. I'm going to say it was a couple of days, fitting in to different spots during a week, and that got that done. So that's the effort level we're talking about to invest in, and the stand-up time that you'd be looking at for this kind of a system. Taking a look at the architecture here, we're talking to ControlLogix PLCs at each plant. We have SE industrial PCs, Lenovo SE30s. That's where we install the Dynix container, which we happen to be using to talk to the PLCs. You could use OPC UA directly from within AnyLog as well. And then we have the AnyLog node, and that's the operator node for AnyLog. That's where, in this case, Dynix, ingest the data into AnyLog. It will have, based on how you decided to model that, it will build your schema and store into PostgreSQL in the case of the City of Sabetha sitting on that industrial PC. It does that for each of the water plant, the wastewater plant, and the power plant. In addition to that, there is a query node that brings that together as one data lake, one contextualized set of data in an ontology, as if one database in one data lake.